So, hello everybody, and welcome to this session on advanced search by Ramandeep, Dhanoa. I'm Shukra Steenhuizen. I'll be your moderator today. For those of you who are joining in from Zoom, and of course to those in the room, welcome to this session. Raman, the floor is yours.
Okay, thank you. Hi everyone, welcome to Advanced Searches. I'm just realizing I don't have the intro slide. I guess I'll just introduce here. So myself, Raman, I'm here from Canada. I am a trainer and consultant with FHIR, and I'm also associating with Dogwood as a FHIR consultant. So my role is basically I do FHIR implementation guides, FHIR trainings, develop reference implementations, so dealing with these different components of FHIR. But for today, our learning objective for today is to define and differentiate between what is forward chaining, what is reverse chaining. We'll try to understand the concept of bulk data, and we'll try to see these different techniques on how do you optimize these search results for better performances. And then we'll go on to see how do we do wildcard searches in FHIR. And if there is time, we will see if we can cover more complex search operations as in filter or query parameters. And I'm assuming in the audience here, we do have prior knowledge or some experience of working with FHIR, working with basic FHIR search. So can you please raise your hands if you have done basic searching and have some experience working with FHIR? So I think almost all of you has. And those of you who are not raising hands, I'm not asking you to leave. But the thing is, I feel like all of us has indirectly worked with some sort of searching. Either it's querying, or either we have done some sort of query operations on databases, pulling data from patient database table or something like that. Even though if it's not in the form of database tables, it can be some sort of web UI, and you're sort of extracting data which is sort of hitting some sort of repository on the back end, right? So those of you who are not dealt with FHIR search before, don't worry, I will still do a quick recap of basic searching. So this is how basic search syntax of FHIR looks like. We are trying to get one patient from the FHIR server whose name is Peter. So this is our HTTP verb get, FHIR endpoint, patient, question mark. This is where our filtering has started. So where name equals to Peter. So this name is actually this predefined search parameter for a patient resource. Obviously, there are other search parameters defined in a base specification. You could have done something like patient where identifier equals to this, or patient whose birth date is greater than, or something like that. So these search parameters, they're available for each resource. So condition would have its own search parameters. Observation resource would have its own search parameter. And then we have prefixes to do things like, as in for comparisons and things like that, right? So if you want to do something like, I want to return observations from the FHIR server whose quantity is greater than 200. So you can use these abbreviated prefixes, as in here in this example, we're using value quantity equals to GT200, but there are other prefixes. Some of the examples are provided here is NE, GT, LT, and we do have for approximation and so on. We also have modifiers, which are used with this colon sign along with the search parameter. So we can do something like, if an information is missing for that particular element and you want to retrieve patients from the FHIR server who has missing emails or something like that. So you can use this missing modifier. You can do something called like using this exact modifier, you can do return me all the patients whose name exactly matches with Peter. So this would be going in.
Does that mean that the first one is case insensitive?
Yes, yeah. So this would be considering the case sensitivity. So this is our quick recap. But agenda for today's presentation is I will be talking about chaining. I'll talk about forward chaining, reverse chaining, and how do we include these additional resources, the reference resources in the response. We will talk about bulk searching, and we'll also talk about some of the complex options as well. So chaining. What is forward chaining? First, let's talk about, so we have condition resource. Condition resource has its own search parameters, right? So if you want to search on condition, like let's say you want to search all the conditions on the FHIR server who has a condition of ear pain, right? So you'll just search on that resource with its search parameter. If you want to search on patient and retrieve Adam, you can just search on patient resource where name equals to Adam. But let's say you want to query condition resource related to ear pain, but that also reference Adam Everyman, right? So this is basically, we are dealing with two FHIR resources here. How do we do that? Because condition resource has a reference to patient resource, right? And this linkage is done with this patient reference search parameter. Since we have this linkage, so we would be able to do this chaining to actually search for the condition resources who are actually related to Adam Everyman. And we normally follow the logical path of the resource and do this forward chaining. So how our query will look like for this one? So we'll start with our endpoint. What is our focus resource here? We want to get condition where code equals to 16 whatever, right? Ear pain code. And patient, which is the connection between them, patient.identifier equals to 10, 20, 30, 40, 50. So you might be noticing here that we are chaining our parameters here. So if you're looking closely here, code and patient are actually condition resource search parameter, and identifier is actually patient resource search parameter. And we could access this parameter because we are chaining using the chaining concept here. So instead of identifier, you could have done other patient search parameters as well. You could have done, where patient.name equals to Adam, or where patient.family equals to Everyman. So, but here we are just retrieving Adam from the identifier.
Maybe just one quick question, because identifier cardinality can be 0 to many. So what if you have multiple identifiers? How do you know specifically which identifier you're looking at?
In this case, I'm not showing it properly because identifier is a token search parameter, so you can specify actually which system, you can specify the coding system and the identifier value in that sense. So I think when you're actually searching identifier, it's better to specify the coding system and then specify the value. But in this case, it will just scan all the identifiers and will pick up whatever patients has the identifier. So then comes the reverse chaining. Reverse chaining is basically going in the backward direction. So let's say we want to query for patient resources who have had ear pain. So basically we are going in the backward direction here because the direction reference is from condition to patient, right? So when this happens, we use a special syntax called _hash. So we'll start with patient, because this is our focal resource. We want to return all the patient resources, right, who had ear pain. So we'll start with patient who has condition, which is the other linked reference resource name, condition, and then patient. What is the linkage between them? What connects patient and condition resource? It's a patient search parameter. And then actual filter where code equals to ear pain. So many colons, but the first one is has the connected resource condition. What is the connection between them, which is patient, and then actual filtered. Now, let's say we talked about forward chaining, we talked about reverse chaining, but let's say we want to include these reference resources in the response bundle. So in my first slide, and when I was talking about forward chaining, right, our focus was condition resource, and we were just returning condition resource in the response, even though it was related to patient Adam Everyman. But there may be use cases where we would need those reference resources in the response as well. We are also interested to see patient resource in the response. So to do that, we have this special syntax called _include. So we'll do something like, give me all the conditions where code equals to ear pain and include patient resource as well in the response. So this will also include the patient resource in the response. And as we've already talked about, reverse chaining, which is basically going in the backward direction. So when that happens, we normally use rev include parameter. So this query would basically, it is querying for patient resources with name Adam, and it is reverse including conditions that refer to that patient. So include and rev include to include other additional reference resources in the response bundle. So I have a quick video here to basically demonstrate what I just explained. And if you guys have, if you guys want to do this along with me, feel free to open up your Postmans or Insomnia. That's completely fine. I have pre-recorded this because I really don't trust happy server or public servers out there. So that's the reason I have recorded it. And let me know if you guys want me to stop anywhere. So I'm using the happy public server. Hopefully it's clear for the people who are back there. We have front seats here. So I'm starting again with the condition. So endpoint is happy. My focus resources condition where code equals to ear pain. So when I do that, it will return me a bundle in the response, and in the entries, you can see that I have all these condition type resources with the code of ear pain. And I would have more entries for condition, and ear pain is the code. And I'm using this, helper function Insomnia, which basically shows me all of these entries in the bundle. I think it's easier to see if it's a big bundle, then it's easier to see. So with my helper function, I can see that I have these 15 condition resources that matched with this search criteria. Now, let's try to, since this is all the condition resources on the server with the code of ear pain, but I want to restrict it further just to filter for patient Adam Everyman. Or I would say patients whose identifier is 10, 20, 30, 40, 50. So when I do that, you can see we have now less number of condition resources, around 7 condition resources matched with this search criteria. So in this response, we just have, in this bundle, we have our condition resources returned, right? As you can see, there are no other reference resources returned because we haven't yet included these additional referenced resources. So let's try to add that referenced patient resource as well. So I'll use that underscore include parameter equals to condition : patient. So once I do that, if I scroll down to the bundle, you will see here we are looking at our patient resource. So we have the patient resources also returned in the response as well. And for this particular patient, our search mode would be include. The reason is because this was a part of our include parameter. If you scroll up and look at the condition resource, our search mode would be matched. So that means that that was actually our search criteria there on the top. And if you see here, now we have condition and patient resources returned in the response. So this was forward chain. Yeah.
So then we set for this patient identifier, the last 7 patient resources, are they all duplicates?
Sorry, I couldn't hear.
So we have 7 patient resources, but we restricted the search to patient. We have 7 patient resources, but we restricted the search to patient identifier 10, 20, 30, and so on.
Yeah.
So the 7 patient resources are actually 7 times the same.
It's test data. Yeah. Yeah. It's all messed up. So this was forward chaining. Let's move further to a reverse chaining. So again, using our happy endpoint, here I want to return all the patients who had a condition of ear pain. So obviously I'll start with patient who has the connected resource would be condition. And what is the link? Patient, and then actual filter, where code equals to ear pain code. So you can see in the bundle response, we have these patient entries who have actually condition of ear pain. Now, again, I would try to include additional information with that. I would want to have condition resources in the response as well. But I'll just use my helper function to see what is in the current response. You can see we have around 13 patients here, and we'll also include our condition records for these patients. So I'll use rev include, resource name, and the reference search parameter. So obviously lots of conditions here. But basically, the whole point is to show that now we have also included all of those condition resources. All of these condition resources are referencing these patient resources here. So that was all on chaining and includes. Let's get started on searching, bulk searching. So I think every one of us has worked with $everything operation, at least heard about it. It sort of returns all the data for a particular patient ID. So whatever is configured, obviously, on the back, on the server. But let's say we have 50 different resources connected to the patient, and we are just interested to return observation type or something like that, right? So there is this underscore type parameter, which basically tells you what type of observation, what type of resource you want to return. So here I'm saying I am only interested to return observation and condition for this particular patient. So when I execute that, it will return me observations and conditions for patient 1, 2, 3. We have underscore since parameter. So this basically returns me all the resources that have been updated or modified after this timestamp. So that, and this basically executes on meta.lastUpdated element. So it would just pick up the updates and show the response accordingly. And then we have underscore type filter. Let's say you want to return the resources who is basically matching with a certain criteria, right? I want to return all the observations from the FHIR server whose status is final, right? So in that case, we can use type filter. This is not commonly used, and it's not even implemented in any of our test servers, but this is there in our bulk search specification. And then we have export operation, which can be obviously used to export data, and we can use these different types of other bulk data operations to use with that. So this would basically export patient data, which has been updated since this date. This would export observation data since this date. This would obviously mean the same thing. This is not an exhaustive list. There are other types of bulk search parameters and operations available on this specification. So feel free to browse this one if you guys are interested to look onto more parameters related to bulk data. And then there's another way. We can also do bulk access through bundle as well. So FHIR bundle resources can also be used to process large number of requests at once. So it is normally accomplished by making this single request, which has these bundles of several individual requests. So we are sending this bundle to the server, but you can see in the entry, our first entry, we are saying, get me all the patients where name equals to Smith. And our second request is get me the observations where code equals to this. And then we are saying, I need all the conditions for this patient 1. So basically 3 requests embedded within our request element in the bundle. And I do have a quick demo of our bulk access parameters. Our happy public server, it doesn't support some of the parameters. I'm using Firely server to demo some of the parameters. So obviously the first one is returning everything for patient 1. So using $everything operation. So when I do that, it will obviously return me a bundle with different resources in that. You can see we have care team, and then we would have goal for this particular patient, for patient 1. We have condition. So basically everything whatever is connected are being referenced to patient 1 is returned in the response. So if I do that, you can see we have quite large number of resources connected to patient 1. But let's say I really don't want to deal with these many resources. I'm just interested in observation resource, right? In that case, I can use something called _type. So I would just do FHIR endpoint, where type equals to observation, and patient equals to the reference of patient. So if I do that, this will basically return me only the observation resources for this particular patient. By default, FHIR server only returns these many observations, but obviously you can always use _count parameter to, I'm just using 200, just a random number, but you can see we have around 50 observations for this patient 1. Now, let's say these are the number of observations which are there for patient 1, but let's say we want to return all those observations who have been updated since this last year, right? We only want the recent observations. So for that, I am using _since parameter. So once I do that, I'll use _since 2023 01 01. So once I do that, same number of observations. And I think that's because all of these observations have been updated since this last year. So we can actually check that by looking at its meta.lastUpdated value. So you can see all of these resources, observation resources, have been updated in this year. And the last demo I wanted to do on bulk access was requesting the data through a bundle with these different entries. So I already had my body prepared. So I had these 3 requests embedded in this bundle. So I'll post that in the JSON format. And I'm using Happy FHIR server for this. So you can see in these are the 3 entries. First entry is get me all the patients whose name equals to Smith. And I also want to return observation records for Smith and also medication request for Smith. So once I do that, you will see in the bundle, we have an entry of bundle which will have further results embedded in it. So bundle with entry of patients. You can see it's confusing. So we have bundle, 3 bundles. The first bundle has the results for patient. This is my second bundle, where if I scroll down, it should return all these observation resources for Smith. Yeah, and hopefully this is the ID for him. So this is my second bundle. And then I would have third bundle, which would basically return medication request resource for Smith. So you can see in this bundle, we have these 3 entries, which are also bundled. So that was our bulk access. Let's talk about a little bit more complex options here. Wildcard searches. We do have wildcard character in FHIR is with this asterisk sign. So for string parameters, if you do something like patient where name equals to SM star, this will find me patients whose names start with SM. If you'll do something like star SM, so it will find me the names who are actually ending with SM, whatever is there on the front. And then with the token parameters, we can use this wildcard to find resources that have any value for a given element. So if we do something like observation, where code equals to loink, so this will find me the observations that have a loink code of any value. So you can use this if you're interested to return a specific set of or specific coding systems or things like that. We have these different parameters in FHIR, summary, elements, basically to control and optimize our search results. It's possible that you're getting this vast amount of data in the response, right? How do you deal with that performance-wise? So we have these different parameters which you can use. So you can use _summary. So if you'll do something like that, _summary equals to true, this will return only a set of elements within that particular resource type. So let's say in the on the server, you have already configured that for patient resource, I want to return name, birth date, and gender. So you already configured that. If you're returning patient and setting this flag to true in the response, when you're returning your patient resource, it will only return name, birth date, and gender. Now let's say you're also not interested in gender. You can also do something called _elements. Where you're returning the patient, and return me just name and birth date. You can always use count. We have page to return all the observations where count equals to 5 and page equals to true. So if you have large data and it's divided between different pages, and to navigate from one page to another, you can actually jump to page 2 or page 3 with this page search parameter. And we do have sort. We can sort the observation data using this sort function. If you'll just do sort equals to date, it will just return the observations in ascending order. But if you'll put this little dash or hyphen in front of it, it will sort the result in the descending order. More complex options. We have text parameter. So this text parameter basically searches on the narrative portion of the resource. So if you do this, it will just find John in all the narratives of the resources, and it will return all those resources who has John in the narrative. You have content. So along with the narrative, it searches on narrative plus the discrete elements or structured elements as well. So this would be basically that full text-based search. And then we have filter. Filter is used for more complex searching, right? So you can, there are some areas where you cannot do normal searching through URLs. So in that case, you can use filter, and this is how the syntax of filter, just an example, return me the patients whose name equals to Peter and birth date is greater than this date. We also have query parameter. So this query parameter is basically, we do our queries, and let's say we really have this complex query and we really don't want to execute it again and again on the URL. So we basically embed that query onto the FHIR server with this named query. And as a client, I can just invoke that query whenever it's needed. So you can use _query equals to, if I'm doing recent observations, I'm just interested to return observations within last 1 week. So I can do something like that. Obviously, with filter, we do have more control of, you can just create filters on the fly. But if you have something like that, and you know that it is needed for your use case to reuse that again and again, so you can use _query. I think that's all for me.
All right, so thank you, Raman. If there are any questions in the room right now, just raise your hand and I'll give you the mic so everybody in Zoom can listen in. No questions from the room? Yeah?
Can you go a few slides back with the asterisk? So I remember that if you have a string parameter, it's actually always doing a prefix search. So is this behavior changed in version 5, or why is this necessary?
Sorry, prefix search?
Yeah, if this search parameter is of type string, then it usually does a prefix search, and if it's of type token, then it does an exact match. And otherwise, if you have to do the exact search with the string, you have to do this modifier parameter exact. Is this changed? Because otherwise, this asterisk would just be ignored.
For the string, we would do that SM star, right? But this one I was talking about a token parameter. So you went with this one?
No, my question is about the first example,
For this
because
one, yes.
because if you just leave the asterisk, at least in FHIR version 4, it would just be the same because it's always doing a prefix search. Depends on the server. Okay.
Yeah, how it's configured and stuff. Yeah.
Okay, thank you.
Other questions? Yeah.
If we're moving forward to the next slide, there was something on the sort. And here I wonder what you think about the sorting algorithm, because there is quite a challenge in that, I would say. So he says, I was ascending, descending, well, a piece of cake, but how to sort?
I have no idea about that. The FHIR experts are here to talk about, I mean, I really don't know what's happening with the underlying algorithms, if that's where you're wondering. I mean, are you going into indexing and that sort of stuff? Like if it's been implemented?
Yeah, give me an example of the alphabet. So, so we're sorting a text string. English language, A to Z, easy.
Yeah.
Take German, my mother tongue.
Yeah.
So we have some extra letters in that. So you need to consider that, to honor that, and.
Sorry, I really don't have any answer for that,
No
but I'll
problem
look
with
into.
Usually the answer when it comes to search is it's up to the server to decide how they do this.
So I think Graham has an answer to that.
Well, I mean, Renee was right. It is up to the server, and that's actually deliberate because servers put a lot of thought into how they sort these things, and we were never going to get consensus around how to fix that down, and so it's up to the server.
Mm-hmm.
Thank you. So, Raman, I also have a few online questions from WOVA. So the first one is, what is the best approach for filtering? Is an advanced filter the best approach, or ECL in FHIR?
I'm not sure about ECL, is it? But I feel like if I really don't know how do we differentiate or how do we draw the line between searching and advanced searching, because even though I talked about chaining and includes in my advanced searching topic, but I really feel that is the basic searching we do need, like as in our clinical decision support systems, right? We have patients, we really have to link our patients with conditions and observations, and we have to do forward or reverse chaining and include additional information, right? So I feel that is the basis of our searching, chaining, and also these other parameters I was talking about, controlling, optimizing search results, right? So these are, I feel like it would be just useful in our normal day-to-day life as well. Even with the bulk search, right? Let's say we are sort of scanning this population health, right? Where we want to scan the population based on what kind of disease the population has. And in that case, bulk search would come into picture. So I feel it really depends on your use case, what you really want to do.
Yeah, thank you. And then next question is, will content do full text search only in the specific resource or other resources associated with it?
We'll do on all of them, yeah.
Yeah. Perfect. And are there any questions in the room still? Yeah, one.
A short one. Sense and last update.
Wait a second.
It's a short one. I mean, sense and last updated will return the same result for the same type of the resource. Is that right?
Sense would go on to meta.lastUpdatedElement to see when this instance got updated.
Exactly.
Yeah.
So I don't see the value of using sense when we can do last updated. We can do, for example, condition question mark last updated equal.
Right. I
greater
think it
than.
would mean the same thing. Yeah.
It's, okay, but the only difference, and please correct me, this is for the bulk usage, right? So sense will
Yes.
return everything, not all.
Yes.
Okay.
Yes.
Thank you.
I saw another question in the back. No questions? All right, I have another question on WOVA, which is, can you combine search? For example, if you have a patient with age higher than 18 with a specific medication, that is, can you provide a search for that? Well,
Yeah. You can use patient. What was the question? Where age equals to?
yeah, so the age higher than 18
Yeah.
and with a specific medication.
Yeah, so you can obviously, if your focus is patient, if you want to return patient resource, you'll just do reverse chaining to a medication request resource and do that, accomplish that through chaining,
Yeah.
reverse chaining.
How would you do the age then?
Birth date,
Okay.
yeah.
So there is no way to use age extension.
Age is not a search parameter in the specification. Yeah.
Yeah, so you would always use birth date there. Yeah.
Yeah.
Perfect. Thanks. Are there any other questions in the room over here? No more questions? Let me check WOVA real quick. So I think we almost done with WOVA as well. Yeah, so I think those are the last of the questions then in that case. So Raman, I would really like to thank you for this wonderful
Thank you.
talk of you. It's really been great.
Thank you.
Big applause. So thanks a lot, everybody, and yeah, enjoy your next session.